The important thing of a paired t-test is to know when it's appropriate to use it. So a paired t-test, we're not talking about replicates of a sample, we're talking about different samples. So you might expect them to have different values. As an example, let's say we have two methods, A and B, and we're going to use them. We want to see if they give the same kind of results. So we're going to use 4 different samples, sample 1, 2, 3, and 4. And the values we have, sample 1 is 10.2 and 10.9, 2 is 20.5 and 19.7, 3 is 2.7 and 2.6, and sample 4 is 35.5 and 35.4. You can see these are not replicates of the same sample, they're very different from each other. So we can't use our regular t-test for comparing two sample means. What we can say though is that if these were given the same result, then the difference between them should be 0, or within significant error, or within significant difference. So we can subtract the 2 and take the mean of that difference and see if it's significantly different to 0. So if we do A minus B, the difference here is negative 0.07. We do keep the negative. For sample 2 it's positive 0.8, sample 3 is positive 0.1, sample 4 is positive 0.1. Once we've done that, we're now going to do the test just on the differences, so we can ignore the actual values for the sample. So what we want to do here is use this set of data now. So we're going to take the mean of the differences, which is 0.075, the standard deviation of the differences, which is 0.613, and then the number of differences, which is 4. Again, we're just looking at the differences now. So then we apply our equation to get a value of t based on the differences. So our experimental value of t is the absolute value of the mean of the differences. I think I used x bar before, but we're going to use d bar now. Doesn't look much like a d. There we go. Then multiply that by the square root of the number of differences and divide by the standard deviation of the differences. When we do that, we get an experimental value of 0.245. And then we would look up a value of t in a t table, 95% confidence. And remember, now we're looking at degrees of freedom. So there are 4 measurements of difference. So n equals 4, so that means 3 degrees of freedom. So the critical value of t from the table is 3.18. Our experimental value is less than the critical, so we accept the null hypothesis, which is saying that method A and method B give us the same results in terms of the mean.